Recall from a previous video on classifying alkenes, that you can have 4 different types of alkenes: monosubstituted, disubstituted, trisubstituted, and tetrasubstituted. And those are based on the number of carbons that are attached to the carbons in the double bond. We talked about how the more carbons that are attached, so 1 mono, 2 di, 3 tri, etc., 4 tetra, the more carbons that are attached, the more stable the alkene becomes. And that was because of hyperconjugation. Each of those, the alkene, the pi bond, is formed by parallel p orbitals. If we, right next to it, the carbons that are bonded to the alkene are in sp3 orbitals, and one of those sp3 orbitals lines up a little bit and allows the electrons in the pi bond to spread out a little bit. And so we see that happening here. If you zoom in on just this part, that's one of the p orbitals in the pi bond, and then we have a methyl group here. You can see the sp3 orbital in front is coming out at us, the one in the back is going away from us, but the one up is sort of in the plane with the p orbital, and so they're able to sort of bleed into each other a little bit. And that lets the electrons in the p orbital, in other words, the electrons in the pi bond, to spread out into that sp3 orbital. And the more atoms spread out, the more stable they are. So that we've seen before, that much. Now we want to just revisit that and recall that effect on stability. So we're about to do something a little bit more complicated with this information. This exercise is just sort of a rest stop to take back, collect ourselves, review what we already know. So we want to classify, it says to arrange each of these alkenes from least to most stable in order of increasing stability. I guess they don't say specifically increasing, you could do it in decreasing, but you just want to make sure you label it. So here we'll do it in increasing stability. And what you want to do is first put dots on the ends of the double bond. Then you want to ask yourself, are each of these double bonds monosubstituted, disubstituted, trisubstituted, or tetrasubstituted? Okay, well, the carbon on the first, let's start with this one. This is bonded to 1, 2 other carbons. The other one is bonded to 1, 2 other carbons. And so that is tetrasubstituted. This one in the middle, the carbon at the bottom is bonded to 1, 2 other carbons, and the one on the top isn't bonded to any, so this is disubstituted. For this one on the right, this is bonded to 1, and the other carbon is bonded to 1, 2, so that is trisubstituted. So if we were putting them in order of increasing stability, the least stable one first is going to be this disubstituted one. The electrons in the pi bond can only leak out in 2 places, and so they're not going to spread out as much as in the others. So we would have the least stable, the trisubstituted is the next most stable one, because it's the next most substituted. So that's our second one, and then the most stable is the tetrasubstituted alkene. And that was this one here. So this was least stable. Because it's the least substituted, and this other one was the most stable because it was the most substituted. Okay, we can follow that same sort of line of thinking with B, same idea. Put pink dots on each of the carbons in the double bond. We want to think how many carbons are bonded to those pink dots. Well, we have 1, 2 in this first one, so that's going to be disubstituted. There's only 2 carbons coming off of those. Notice we don't count the bonds in the double bond. It's just coming off of the double bond. So in this other one, we have 1, 2, 3, so that's going to be trisubstituted. And in this last one, we only have 1, so mono. substituted. So the least stable is the one that has the fewest substitutions, the one that has the fewest branches, carbon branches coming off of it, because in that case the electrons in the pi bond won't be able to leak out as much. And so in that first molecule we would have this is our least stable. The di substituted is the next most stable. So we'd have this one. And then the most stable of all is the tri substituted in this series. Oops. And so this is the most stable. So as the number of branches that are attached to a double bond increase, the double bond becomes more and more stable because the electrons in the double bond are able to leak. They're able to leak out into partly into the sp3 orbitals through hyperconjugation. And the more they do that, the more stable that charge is. Okay, so we're going to use this piece of information, the stability of alkenes, based on how substituted there are in our future problems.